So here we are in the supply and opportunity cost experiment, and I'm sitting here in round 2, and I'm going to read the instructions just to remind myself what's going on. You have the capacity to produce and sell up to 3 units of output. Each unit sold results in additional fuel input cost of $1, $3, and $5. And each unit that I sell requires a single allowance, which is a pollution permit. I've been allocated 2 allowances at no cost, so that's an asset. And if you use additional allowances, they must be purchased for $3 each. If you sell fewer than 2 units of output, I can sell those and earn $3 for each sale. So the opportunity cost of each allowance that I am holding is $3. Okay, so that's a cost that should be considered in each of my production decisions. So in this round, the going market price is $8.50, and I need to choose my production quantity by deciding whether to produce. There's a typo or not for each unit. So for each unit I produce, there's a cost of $3, whether I'm buying or selling the permit. So my cost for the first unit is $4, my cost for the second unit is $6, and my cost for the third unit is $8. The price is greater than each of those costs, so I'm going to produce 3 units of output. And I earned $13.50 on that transaction. So now let's go to round 3. Everything's the same, but the going market price is $1.50. Okay, so even though the market price is greater than my fuel input cost, the market price is less than my total cost because I could sell my allowance for $3. So my revenue in this round would be $1.50, but my cost is $4 for the first unit, so I'm not going to sell any of these. And I earned $6 by selling both of my permits. So now I've jumped ahead through the first 8 rounds, and I have followed that decision rule where I produce as long as the price exceeds the fuel input cost plus the opportunity cost of the pollution permit of $3. So as of the end of round 8, there are 23 participants who have finished 8 rounds, and the total earnings range from $42.50 to $65.50, and my rank is 1. I'm in a tie with 2 others, and so a couple of y'all figured that out right away, and we're making as much money as possible. So now I'm going to go ahead and begin round 9 when things change. So part 2 of this experiment, so some payoff parameters have changed. The initial allocation of emissions allowance has decreased from 2 to 0. So what this experiment simulates is going from a cap and trade permit system where polluting firms are given pollution allowances, emissions allowances, and allowed to use them or sell them, to now we've gone to a pollution tax system where in order to produce the product we have to buy an allowance at $3 each. So everything has stayed the same, except now I have 0 allowances. So now the cost is explicit instead of and implicit opportunity cost. So actually the decisions get easier once we get to part 2. So now at a price of $8.50, my cost to produce 1 unit is $4. So I'll produce that first unit. The cost to produce the second unit is $6. I'll produce that. The cost to produce the third unit is $8, and I'll produce that. And I made money on each unit I produced. So let's begin round 1. So now the going market price in this round is $7.50, and so $7.50 is less than $5 plus $3, and so I'm only going to produce the first 2 units. Submit and confirm decision, and I made $5 that round. Yeah, so now that everyone has completed the experiment, we have the results here, and let's see if I can disable refresh. There we go. So now that everyone has completed this, we've got the results, and the first column over here tells us the round and the earnings efficiency. The earnings efficiency measures how much money you earned relative to how much you could have earned. So 69% means that for every dollar that could have been earned, the group of firms participating in this experiment earned 69%, or 67 cents. So earnings efficiency rose from 69 to 82 to 87, 86, 87, 87, and we get to the last 2 rounds, and we're earning 96% and 93% of total earnings. So there's some learning involved. So y'all were figuring out what was going on with the experiment in those rounds. And then in treatment 2, earnings are 82%, 83, up to 90, and round 11, back down to 84, back down to 81, back up to 94, 94, and 91. So the second set of rounds with the tax, it was easier to figure out what was going on, and so earnings efficiency was higher. And here we have the IDs of participants, and you can see how much everyone earned. There's an 83 with ID 12, and that's the most money you could have earned in this experiment. ID 17 earned the most, and then ID 28, which was me, earned the most money possible in the experiment. And just to make sure you know, I'm not bragging. I've done this experiment a number of times, so I know how it works. So let's look at the results. So here's a graph of the average production quantities by price, and I'm going to show the prediction. And actually, this is round 1, and once I hit the prediction, well, let's see. Let me click on treatment 1. Okay, so there is the summary for treatment 1. When you were allocated 2 allowances for free, and the key to making the most money is to recognize that each of those had an opportunity cost that you could sell them on the market for $3. So we see a lot of dots here. These are your decisions as the price goes up. The bold line is the prediction. So take a look at when the price is $3.50. So the market price is below the sum of the fuel input cost and the revenue that you could have earned from the allowance. And so the total cost is $4. And that's where we get this horizontal line between 0 and 1 at 4. Okay, so the firms participating in this market were selling, instead of selling 0 units when the price was below 4, we were selling more than 0 units and losing money as a result. So every time a dot is below the theoretical supply curve or the predicted supply curve, we're losing money. Okay, and that happened up until the price of 850, when the decision is a whole lot easier. Okay, in treatment 2, we were still oversupplying the product until we got to prices above $6. So when the price is below $4, we're losing money or not paying attention to the tax, to the cost of purchasing allowances. Same thing happens at a price of $5.50 and $6.50. But these mistakes that we were making are much lower because that cost is explicit. All right, so now let's go back to the results and let's look at the data. Here the data is laid out in each round. We've got your ID number and the unit that you could have sold, bought and sold, 1, 2, and 3. Fuel input cost for 1, 2, and 3 is 1, 3, and 5. The emissions allowance price is 3, 3, and 3. It stays the same. And then the randomly drawn price is 250, or 550, or 150. And then the decisions made are unit sales for each round. It's either a 1 if you sold the unit, or 0 if you did not sell the unit. And then there's a quantity sold that adds up the number of units that you sold in each round. So for round 1, ID 2, units were sold for the first and the second cost, and then so adding those together, the quantity sold is 2. And so total earnings were 1, cumulative earnings 1, and earnings as a percent of the maximum that you could have made was only 17%. And that's because this price, 250, was below the allowance price, and at a price of 250 you should just produce nothing and sell your allowance. And so I have taken these data and done some statistical analysis with them to summarize some of the things that we were doing in that experiment. So we have, let me go back up here. So here's a table of the descriptive statistics where we have a bunch of variables, and when I imported this into my software, it truncated a lot of the variable names, but we still have ID. You can still read these. They're ID, round. The unit goes from 1 to 3. The fuel input cost goes from 1 to 5, 1 to 3 to 5. The price, randomly drawn prices, were range from 1.5 to 8.5. Unit sales is a 0, 1 variable. 1 for equal to if you sold it, 0 if you did not. And on average, we sold 47.5% of the units that we could have sold. The quantity is the sum of the sales in each round. So the average was 1.42, and that ranged from 0 to 3. Earnings in each round range from minus 10.5, where someone lost a bunch of money in one round, to a maximum of 13.5. Cumulative earnings adds all those up. X10 is the percentage earnings. It goes from 0 to 10 to 100 for each person. And the tax variable, this is a 0-1 variable that's equal to 1 if the unit of observation occurred in the last 8 rounds. So this is when we were having to pay the tax, purchase the allowance in order to produce the good. And then we'll ignore the rest of those variables. One thing we will check out, there's 1,056 cases of data, lines of data in the data set, and that's a lot. We have like 23 students and participated in 16 rounds. Or let's say, I'm not sure how we got to 1,056. There may have been some missing rounds in there. Let me go back to 1, 2. So here's my 3 regression models. And this is the same sort of output that you are getting from Excel, except that I, with these data, took account of the repeated observations that we have, because because each of you are in the data set 16 times. So ordinary least squares ignores that repeated measurement. And so in my command, I specified that there were 16 periods, which allows the error term to capture a constant error for each person. So there's some more statistics behind that, but in short, this is a better model than if I just ran it all by itself without accounting, without telling the computer that there's 20-some people who participated in the experiment and not 1,056 independent decisions. Okay, so here's our model where unit sales, so I regress unit sales on a constant, the fuel input cost, the price, and the tax treatment. So this is the linear probability model. So as the fuel input cost goes up, you're less likely to produce the good. For each $1 increase in the fuel input cost, the probability that you'll produce the good goes down by 15%. Each time the price goes up by $1, you're 11% more likely to produce the good. And then in that second round, that second treatment of 8 rounds, where you had to explicitly pay a tax, the probability that you would produce the good goes down by 13%. And all of those changes in the percentage is based on the base percentage of 43%. In the second model, regresses earnings. So I'm trying to determine your earnings. This is your whether you earned 0 or 100% of potential profits, and see how that matters based on price and tax. And we get a similar result. As the price goes up, earnings increases, and the tax treatment, earnings decreases, because where we once had an asset, we were given an emissions allowance. Now we're having to pay for it no matter what. And then the last model, I regress the quantity, the total quantity that you sold, which would be either 0, 1, 2, or 3. Regress that against the price and the tax. And again, as the price goes up, you sold more, and as the tax went down, in the tax treatment, you sold negative 0.39 fewer units, or 0.39 fewer units. So if y'all participated in this experiment again, after going through this consultant's report about how important the opportunity cost is, the idea is that this coefficient on the tax treatment would be 0, and the t-stat would be less than 2, indicating that people who participate in the allowance market or have to pay a tax behave identically because they recognize that the opportunity cost is real money. Every time you ignore the opportunity cost, you lose money. So hopefully if you participate in this experiment again, that number would be 0. And here's a simple Excel plot of the data from the model from the supply curve. The numbers in my B column here are the coefficient estimates, and the A column are my variable names. And down here I have the price that ranges from 0 to 10. And for Q1, this is when the tax treatment is 0. And I've hard-coded the coefficient estimates and multiplied the price coefficient, 0.33, by the price. So B2 times D6. And in Q2, I've done the same thing, but added in B3, the effect of the tax treatment or the different policy regime on the model. And so what we get is this supply and opportunity cost graph. This is the supply curve that is generated by your data and then estimated in a regression model. So we have a nice straight line supply curve. Okay, supply 1 is when you were given allowances, and supply 2, the blue line, is when you were taxed. So we get a significant decrease in the supply of the good when we have a tax, but all that means is the product is oversupplied in the first 8 rounds when the opportunity cost of the emissions allowances were ignored.